E-commerce today has become a very popular mode of buying and selling, especially with the introduction of recommender systems. Recommender systems are systems that suggest or replace existing products with other products based on a collated data on the user or previous interactions with the site. This is a working example of a recommender system. This e-commerce store's recommender system suggests phones and shoes to the logged-in user based on information gathered about the user. In today's world, where social media has an impact on our daily lives, including our shopping decisions, these applications collect and retain information about us that reflects our preferences. It is critical to include this data in the recommendation process. It is also crucial to consider how it may be utilized to improve recommender systems as well. The goal of this project is to provide an overview of how social media data may be used in recommender systems. To create such recommendations, we will leverage Twitter data via their developer API in this project. As you can see, user A mentions user B in a recent tweet, and she responds by mentioning him in her own tweet. In one of his latest tweets, another user, user C, mentions user A. A network graph is built from these three tweet scenarios, demonstrating how these three users are related based on their mentions. Because of their encounter with user A, the three are linked. When many users mention each other and react to each other's tweets in real time, the network graph connects each user node, and a network or connection is created or made among users with each follow, like, retweet, and mention. The concept of this project falls on the basis that we only follow, mention, or retweet tweets of users that we relate to or share similar interests. This is where the idea of collaborative filtering plays. When a user logs into our sample e-commerce site, the site sends the logged-in user Twitter's username to the recommendation module, which then processes the input, creates a network of all possible users connected to the logged-in user based on the data collated from the user's tweets, and returns the username of the user closest to the registered user based on the network metrics table generated by the recommendation system. The site engine then queries the database and recommends the recent order of the closest user to the logged-in user. This recommendation procedure, and gender trends as friends in the same peer group can purchase the same item. Thank you. This is a simple demonstration of the system. From our previous example showing user A, B and C. User B logs in. Selects products to buy. Below the checkout section, you can see the products user A bought is vividly showing as a recommended products for the logged-in user. Paystack API is used to facilitate payment. At the back end, we see that user A is the closest to user B. Hence the recommendation.